Okay, let's talk about setting up your first MD Solids report. We already know how to do a lot of this math by hand. We're going to use MD Solids to make a lot of it, to make it a lot quicker. I'll show you how to generate these reports real quick. So let me close out of this so I can show you. Let's open up MD Solids. If this window comes up, hit cancel. And we're going to do an interior beam for this scenario on 326. We want to select this beam, and it is 18 feet long. And location of left support is at 0. Location of right support is at 18. And hit enter. And what we calculated with, let me bounce back to something. So it already gave us our loads, so a dead load of 50 and a floor live load of 100 PSF. But what is this beam actually going to carry? So let me open this up so I can draw on it. Remember a while ago we talked about tributary width? So if we're going to do this interior beam, let me figure this out real quick. Okay, if we're going to do one of these interior beams, let's say this one. So that interior beam, ask yourself, what is that beam supporting? Well, that beam is supporting half the distance to this beam. I'll try and draw this as straight as I can, and half the distance to this beam. So this is our tributary area, half the length on each side. So if we look at our measurements from beam to beam, we're 6'8", so that's 3'4" on one side, 3'4" on the other side, which is 6 feet 8. So we have to convert that to a decimal, and then we have to take our criteria. Let me get rid of this. Here we go. So 50 PSF times our tributary width, which is 6 feet 8 inches converted to a decimal, and 1,000 PSF times that same tributary width, 6 feet 8 converted to a decimal. That should get you your total loading. So do those calculations in your notebook. Pause it, make sure you do that in your notebook, and then come back. So you should have gotten 1,000. So then we're going to go back. Now we can bounce back here, bounce back to MD Solids, and that 1,000, the whole reason for that little detour, that 1,000 is going to be a uniform load down. So we're going to select this load, and the start of the load is at 0, the end of the load is at 18, meaning it's going to continue through the entire beam, and there's our 1,000 pounds per foot, and hit enter. So remember, all that math you did by hand, take a second and realize how cool this is, that in a press of a couple buttons we have our load diagram, a shear diagram, and our moment diagram. Specifically right here, our shear, that number is going to be important in a minute, and so is our moment diagram. All that goes into how we choose our beam.